about behavior when a guest comes onto our campus, okay? This is a guest who's taken time out of his schedule and his life to come here and help us. As such, you need to be respectful, which means sitting up, which means looking at the speaker, which means participating when questions are asked, not talking to the people around you, not looking or reading or drawing, but just focusing. Cool? Outstanding. Let's begin with our presentation. That's a little bit of the meeting.
Thank you. All right, hopefully this will keep you guys awake and motivated. You're still working on your stuff? You guys need more time? Good? Okay, like Teacher Beth had just mentioned, I'm here to share what I do and hopefully give you some education, inspiration, give you some tools. You know, I am here on my time to come out here and be with you and share this time with you. I can be back in the office doing something else that, you know, that I put on the back burner to be here for today. All right? Let me take care. All right. So, the title of my presentation is Combating Air Pollution Through Education, Responsibility, and Action. Okay? We can get education, and if you have no action, you know, that just doesn't really go too well. So I would hope that through the education, now I can inspire you guys and act upon what you guys do. So, what is air pollution? What is this all about? Okay? So let's start with basic defining what air pollution is. And I'm not going to try to bore you with some fancy chemical stuff and scientific stuff. We're going to keep this pretty lighthearted, fun, entertaining, and engaging. So if you have any questions, we're going to address that at the end. But let's go ahead and look at what air pollution is. First, it is either particles or some kind of gas, chemical that's in the air that is harmful to you, to me, to the public, and to the environment. Just remember, okay, that it's either a gas or some other chemical or particles. And I had mentioned and I had noticed that now you guys have air filters back here in the back. I don't know if you guys know what this is. You guys ever even pay attention to this? So this is what you would consider to be an air purifier, but that purifier is picking up particles that is in the air. In the last class that I spoke to, instead of being blue like that, it was red, which tells me that there's probably a lot of dust. You know, they're bringing in bad air. So, but you guys are good. This is all blue, so which means good air here for us. Okay. Examples of some of those chemicals. Okay. One of them is called ozone. We look at sulfur dioxide that's in the air, nitrous dioxide, and particles. Okay. I'm really going to focus on the particles, and we're going to see why that is so important when it comes to air pollution and it comes to the public. Okay? So, see that it is a danger. Okay, let's go to what really would be or constitute what air pollution is. Wildfires. Okay? Has anybody been near a wildfire or been involved in one? Yeah, we got one guy here. You know it's not a fun experience. I've heard stories about it. I've never been, been in that kind of situation. However, you can notice that during wildfires, the biggest health concern is particles that are in the air. And these particles are so small that you can't see them. And the example here, you can take the diameter or take a strand of your hair and look how round it is. And that's 50 to 70 microns, right? The cross section. Particles that we look at are down to 10 microns. We even take it a step further and we go to 2.5 microns and smaller. And we'll see that those small particles are actually the most dangerous and affect our health the most. Okay? So here I got a couple pictures of what's going on with these factories here. You see their smoke is coming out of their stacks. This down here, wildfire. Okay? Anybody know what this means right here? What?
Gas is
Go ahead. What's that? Don't smoke. What is this guy doing? Smoking, right? Well, cigarette smoking, yeah, you're polluting air. It's a form of pollution, okay? So there is an organization that looks at things globally throughout the whole world, and they're called the World Health Organization, right? And we want to focus on as individuals, okay? So I told you a little bit about what air pollution is, and now you want to see how does that affect us as individuals. Well, according to the World Health Organization, they say more than 90% of the world's children breathe toxic air every day. My question to you is, are you part of that 90%? More than likely. More than likely. Okay? So keep that in mind. All right. So why should you care about this? Well, those very fine, small particles, the 2.5 microns, the ones that I told you that are the smallest that we were looking at, can give you problems. Shortness of breath, wheezing, chest, fatigue, asthma. If you know anybody with asthma, or if you have asthma, this is what's hurting you. Okay? Ozone. That's a whole different chemical. Okay, that's a gaseous chemical. If you know anything about our atmosphere, ozone is good for us up in the stratosphere. It protects us from the bad, harmful rays from the sun. But once it gets to be around our ground level and we breathe that ozone, then it starts affecting us. We start having breathing issues, sore throats, headaches, if not mentioned there, fatigue, right? Again, people with asthma shouldn't be around outside for bad air quality. Okay? Now, going back here, one thing that strikes me is when you hear stories of somebody passing away from lung cancer and they've never smoked in their life. And this is probably the cause of that. It's the bad air quality. Okay? So, this little girl right here, what's she doing? She got an inhaler, right? So more than likely she has breathing problems. She has asthma. So that's what I do as part of my job, is to make the public aware of how bad or how good the air quality is. So if you do have asthma, you do have breathing problems, and then you can do something about it, okay? Now, talk about what air pollution is, how it affects you as individuals, right? What can you do to be responsible about our air quality, okay? There are things that you can do, right? So, ride a bike, right? Instead of taking your car, 2 blocks, ride a bike. Again, walk. If you're close enough to get to school or get to, a friend's house or whatnot, walking is a good idea. Because then you're contributing to better air quality by not polluting. This one is an interesting one. Wearing a mask. This has all been kind of all new for all of us. We do get a certain amount of protection, believe it or not, from these particles by wearing our masks. However, wearing the correct masks will even protect us further. The N95s, those are the ones that filter out the very small particles, the 2.5s and the 10s, okay? So these are things that you can do to take responsibility. In addition, you can take further action, educate yourself. That's what we're doing right now, okay? I'm not here to just spend my air and talk about something that may be of interest or not of interest to you, but this is what we're here for, okay? So we're here to educate yourself, share your knowledge, share what you know. Why keep it to yourself? That's what I'm doing. I'm sharing my knowledge with you. And you guys are probably the best at sharing that knowledge. How? Give you one guess. What would it be? How do you share your information?
Having conversations with one another.
Okay. Anything else? How about you? How do you share your knowledge? It's something that you hold on your hand. And you use your phone to contact people through what apps? Messenger, Facebook, WhatsApp, social media. You guys got it, okay? You have this tool in your hands that is so empowering, okay, that you can start sharing. And also, not only share, but you can also receive, correct? So keep that in mind. Okay? So don't be like that. Okay? Sure you should. Okay. So continue on. We're going to continue to educate ourselves. Okay? One thing that, as the air advocators, you guys are going to be looking at the importance of air quality, and there are I'm going to talk about the specific sensor called purple air. Okay? The sensor monitors the air quality and it looks at particles. Okay? It doesn't look at gases, it's only going to look at particles. Okay? We're going to go ahead and do a further dive on this, but this is what these sensors look like, and they're all over. They're all over San Diego. As a matter of fact, we'll see they're all over the world. Okay? You can use this as a tool, as part of your advocacy. So, let's go to Purple Air. There's a website. It's www.purpleair.com. And we're going to take a small break from this. And what we're going to look at, okay, let's look at, where do we live? San Diego. San Diego, Spain, Texas, California. Okay. Going to pick up all those little purple air sensors, those little white plastic looking things, and it's going to start populating here. Okay? You can start seeing them turn different colors. Okay, let's look at the colors. Green being good. That means it's good air. Okay? So this area here has pretty good air quality. Bad, obviously, now we're talking red, it's going to be bad air quality, right? Now the numbers is basically the measurement of particles in that air. Okay, so I'm just going to talk about the numbers. The units that we use for this is actually micrograms per meter cubed, but let's just stick to the number itself. Okay, so green, you would probably be right around what, 30, 40, right? The reds, you start getting up about 100, 90. Okay, so you get closer to 100, it starts getting bad air quality. Okay, so you can look at wherever you live. You can go to this website and you can actually click on that sensor and it tells you the levels of the particles in the air for that one sensor in that area. So, it starts from 0 and it goes all the way up to 200, and you can see, it's really low, it goes really high and really low and really high and really low. So if you think about it, during the day, okay, when would you expect the high levels of pollution and particles? Would it be in the morning time? Would it be in the evening time? Or would it be around lunchtime? Anybody have a guess? Would you see why? What level? What time of day? Go ahead.
Rush hour?
Rush hour. Bingo. Rush hour. During traffic. You notice that if you look at this, these peaks right here, more than likely, if you do a little bit closer look, it's probably going to be right around 4 p.m., 5 p.m., 6 p.m. Then it drops off. Right? And it picks up again during that rush hour. So that's why we use what we use. We can start seeing these patterns of air pollution. You don't need them all, but that's what we use this for. Okay. So I want to take, and let's go ahead and go to, has anybody been to India? No. Yes? No? Who has? Anybody? Okay. Well, we're going to go to India right now. It'll take you to India. Keep in mind what our pollution was. And we're going to look at what they have in India. You guys can do this too. So we're at what? What's the highest number you see right here? What, 446? In San Diego, we're at what? 100? 100, yeah. 100, 300, 200. So, you think they got a problem?
Yeah.
Just a bit. Okay? So, now that problem, you can say is, what's causing it? Is it that many people driving cars? People not walking? Factories polluting the air? Well, so these are the questions that you should be asking yourself. What is causing all this? Okay? And, we can go to South Korea. Anybody been to South Korea? How about North Korea? All right, I just thought. Thought I would ask. North Korea. Again, so we can zoom in on any one of these sensors and it can tell you where some of the highest levels of pollution are, right? So I would kind of focus upon this area here and say, well, there's probably a lot of people, there's probably a big city and there's factories probably going on there. Okay? So remember this. This is a grateful tool. This is one of the many tools that you guys can use, okay, as part of the air advocator group. So it's all information there at your hands, okay? So what we're going to do is, if you look at, I don't know if you can see this little bottom corner here, I'm going to click on that. Okay, wait, I'm going to click on this sensor here. It gives me further information, what's going on there. Then I'm going to click on here and it takes me to this page, okay? I can go to any sensor and I can look back in time what pollution was doing, okay? So if I wanted to see what things were during COVID, was there a lot of traffic during COVID?
No.
Probably not, right? Why? We were all pretty much locked down, right? So those are the types of things. If I wanted to go back and say, hey, I want to go back in time and see what was pollution like during March of 2020, April of 2020. So these are the times where there wasn't a lot of traffic going on, so you probably can see lower levels of pollution. Okay? So that's how we get this data from that. Okay. Now, I am, go back. Is my slide here? Okay. Continue. All right. We did talk about wildfires, right? And I think it was you said it was part of a wildfire. You experienced something like that? It was a camping, yeah. Yeah, up in the mountains. There was a fire up in Oregon this past year. Okay. So, isn't it obvious, would you say, that when there's a wildfire, what would the particles be like? Are they going to be really high or really low? It's going to be really high, right? Because you're right there, fire's going on. We already talked about this, okay? So, I can tell, like, right around September, right? They had a lot of particles in there. There's pollution in there. Okay, so there's a fire going on in Grants Pass, Oregon. So, that's pretty obvious, correct? Now, I went to Pine Ridge, California, which is near Chico. And I looked and I said, hey, it's interesting because right around September, the same time, they had really high levels of pollution. They're like up in, 350 almost? When normally, they're almost zero. Anybody catch something here? I'll tell you what we're catching. Grants Pass, Oregon, Pine Ridge, California. How far are they apart? 264 miles. The fire was 264 miles away. And that smoke blew down and we were able to detect it down there. So that's what we call transport. Okay? So if there is a fire 500 miles away, chances are, if the winds are blowing in the right direction, we're going to have high levels of pollution too. Okay? So keep that in mind. So you can see these types of things. This is what information that we have and we look at. Okay? All right. So going back to India. This is a picture of India. Can you guys really see what this picture is of? No, not really, right? What does it look like? A bunch of fog and smog. And there's buildings in there, but it just gives you an idea of what the pollution levels are like. So, I was like, okay, here's an interesting pattern that I saw. Okay? Pattern is right around, what, wintertime, these levels spike up to 400. come back May, June, July, right around the summertime, they come back down. Right around November, December, what does it do again? They go back up, come back down, go back up. Right around December, January, you see these spikes. Here we are presently, we're in November. Guess what it's doing?
Going back up.
Why? Why are we seeing high levels of particles in India during the wintertime? Anybody know? Take a guess.
Maybe since it's so cold, they have to use heaters, which puts
What's
particles.
that?
Since it's so cold, they have to use heaters. That's putting particles and pollution in the air.
Good point. That is a very good point, and that's quite possible. She said that it's probably cold, and people are burning wood to keep their homes warm, which is right, yeah. And that will, definitely. However, there's a bigger problem. They burn their crops during the wintertime. Every winter, you see this spike. And I just read an article. Guess what? India wants to shut down again, not because of COVID, but because of the air quality is so bad during the winter. And this is what you're seeing, this pattern. So, finally, okay, I didn't introduce myself on purpose, but for now, let me go ahead and do that. My name is David Roque. I work with the San Diego Air Pollution Control District. I am an air pollution chemist. My colleague, Daniel Barragan, he is also part of this. He was instrumental in putting this presentation together. We put a small video together. He did that. However, he got an accident on his way over here. So I'm here flying solo. We wanted to share a little bit about what we do in our office, in our lab. So we got equipment. You know, we just don't sit around the desk all day long. So this is equipment here that is being calibrated or repaired. This is another laboratory that we have where we can analyze gas, and we can look at all the different components, all the different gaseous chemicals down there. You know, anywhere between 100 to 300 different chemicals that we look for in gas or in the air. Right here, these are, instead of the purple air sensors to measure particulates, we use a whole variety of different types of samplers. Okay, this is some more particulate samples here. Okay, so we draw air in, okay, and that air passes through a filter on a rainy day when we're measuring for particles. Does the air quality look really bad? Does it look like there's a lot of air? Not really, because this filter is pretty clean. Look at New Year's Day. See that? What happens during New Year's Day?
Fireworks.
Fireworks, smoke. That's what we're seeing on New Year's Day. Don't think about it, but it's there. You don't see it, but it's there. Okay? So this is a clean filter. This is what it should look like if there's nothing in there. This is a filter that we pull and we measure particulates that are 10 microns. So the one on the left, clean filter. The one on the right, obviously, after 24 hours, this is what you get. Okay? Some more pictures of, you know, some of the instrumentation that we have in the laboratories. This one here is looking at metals. So we look at, you know, lead. It's one of the biggest ones that we look at, mercury. So there's a whole different list of all the metals that we can look at in there. And you don't think about that, but the metals are in there. So finally, we discussed what air pollution is about, right? We can define that. How air pollution affects us individually, right? You know, as we mentioned. Now we know why it's so important. If you have problems with asthma, you know, what it causes breathing problems. Taking responsibility for not polluting. And how do you do that? We share the knowledge. We educate ourselves. We walk, right? And if you catch on, the acronym is AIR. about individual responsibility. And with that, I want to show you guys, any questions right now? No questions? Yeah, go ahead.
Okay, so you said that there's like metal in the air.
Yeah.
How does that work?
Okay, so airplane,
Yeah.
aviation fuel, use leaded gas. Yeah. So as part of the combustion, what happens, the exhaust that comes out, right, that lead doesn't do anything. It just comes right back out
In little particles?
in small particles.
And they
And
float?
that gets, suspended in the air. And that's what we're monitoring. And that's what we want to make sure people are.
So lead comes in a form that can float if it's small enough particles?
Pretty much, yeah.
Okay.
It's suspended, yeah. Yeah, and you got, ways that you can suspend it, aerosols is a big So you see that. Yeah, and then lead can also, there's actually a lot of salt in there, obviously being in the ocean, and those particles can cling on to salt particles. Okay? And then that's kind of how things get mixed around and get moved around. So they pretty much will piggyback on something. So, yeah, go ahead.
Can this hurt your, can these little particles hurt your eyes, or just like your lungs?
I would say so. It's a really good question. I don't really focus on the rest of it, the absorption, through eyes, but I would think so. I mean, obviously, if you get bleach in your eye, right?
Yeah.
It's going to absorb. We focus more on the breathing and the inhaling because that's kind of where most of this, what we do, focus on because of lung cancer. Okay. Anybody have any other questions? Okay. So, real quick, I work out of a mobile lab. So I spend a lot of time, testing different sites and different places throughout the whole county. And I don't know if you guys remember MTV Cribs, so I wanted to share a little bit about my crib. I don't know if you guys remember that. So we put together a small presentation here, a small quick video. And, we like to have fun. We like to have fun with what we do, but we take it very seriously because we want to make sure that the public is protected, and that's what I'm here for. But, we're not just a bunch of, weirdos in white lab coats, and we go out and we have a good time. So, just a real quick deal here. Couple minutes. Hey, I'm Dave Rowe, and welcome to my crib. Your crib? My crib.
All right, come over here. Come over here.
Oh, sorry.
Say you? Yeah.
Yeah.
This right here is probably about 100 feet of sample line. I got not just 1, 2, 3. 3 sample lines that we use to push gas through to get it from here to somewhere else. So, got plenty of gas line right here. Let me show you my closet. This is where we keep all the goodies and all the great stuff. Got laptops. I got a cap. Here, tools, plenty of tools. We got tools. We got flow meters. There's a little ball in here that floats up and tells you how much flow is coming in. So, you can either blow into this thing, the little ball goes up, or you can suck into this, and, the ball moves. This is for vacation. When we're going on vacation, this is another type of flow meter here. It's not a suitcase, we go on vacation or something. I don't know if this would be something a little extra big, but we open it up and There's nothing in this. Oh, yeah. This highly protected case. No dents in it. I try not to throw it, but you know. Ah. Temperature. That way, check to see if you have a fever. That works. Pressure. We can also measure pressure, so feel like you have a headache. Check pressure. Lots of good stuff in my closet. All designed in. This right here is my favorite. Alley cat. Not an alley cat, but the name is alley cat. Right here. Super duper nice, hard